Namaste children, and today we are going to discuss a new topic, new chapter of probability, that is the last chapter of class 10. So already you are familiar with the probability in even from the 7th standard onwards. 7th standard, 8th standard, even in 9th standard you have studied about this probability in detail. But in 9th standard you have studied the probability that is experimental probability. Experimental probability. So now in this 10th class we are going to discuss about the theoretical probability or classical probability. Theoretical probability or classical probability. So what is the difference between experimental probability and theoretical probability? And again we will revise the terminology like equally likely outcomes, complementary events, then it is elementary events, sure event or certain event, impossible event, and then what is the probabilities we will discuss here in this 10th standard. With this knowledge we will study the problems related to probability. So what we studied in the 9th standard, see the word probability. So generally in our conversation also we use the word probability. So like most probably it may rain today, or he may probably he may join in the politics, or most probably we call it as this exams may be postponed due to what it is COVID-19, like this reasons. Generally we use in our daily conversation also the word probability or probable. Probability means which may happen or which may not happen. So that is probability we studied in the 9th standard. Experimental probability, see when we throw a coin, so great mathematicians like Laplace, they thrown this coin, and they identified that when the number of trials are increases, the probability of getting a tail and the probability of getting a head both are becoming equal, and they reaches to 1 by 2 or it is 0.5. So as the number of these trials are increased from 1000 to 10,000, then 20,000, like this millions, 10 millions, if we increase the number of trials, then the probability of getting a head or getting a tail will be equal to 1 by 2 or it is 0.5. Means that probability is we calculated by doing some experiment. So experimental probability is defined as P of E. P stands for probability, E is an event, that is number of trials in which the event happened to the number of trials, to the total number of trials. For example, you have considered the head. How many trials we got for the event head, and the total number of trials which were taking place in doing that experiment, that is tossing a coin. So similarly, if we take E is the getting a head, in such cases also we'll get the probability, that is P of E is equals to number of trials in which the event happened to the total number of trials. So if we go on increasing the number of trials, as I said, it is that probability of getting a head is almost equal to the probability of getting what is a tail. So finally, with this we can conclude on the grounds of theory, that is theoretically. So we can conclude that the probability of getting a head is almost equal to the probability of getting a tail. A tail. So that probability is known as theoretical probability. So theoretical probability is calculated as number of outcomes favorable to E to the number of all possible outcomes of the experiment. So here the theoretical probability P of E is calculated as number of outcomes favorable to E to the number of all possible outcomes of the experiment. So here the equally likely outcomes I wrote here. See, when we toss a coin, we get a tail or we may get a head. So we have both equal chances are there for getting head and for getting a tail. So such outcomes are known as equally likely outcomes. Similarly, when we roll a die, on the die we have 6 faces are there, and on 6 faces we have numbers from 1 to 6 is there. So when we roll a die once, we may get 1 or we may get 2, 3, 4, 5 or 6. So again, for all these numbers 1 to 6 have equal chances are there. Such outcomes are known as equally likely outcomes. Equally likely outcomes. What we call those outcomes? It is equally likely outcomes. So examples for equally likely outcomes, as I said, it is when you throw a coin, getting a head or getting a tail is an equally likely outcomes. In our 10th standard, all the outcomes we assume that equally likely outcomes, and we will find the theoretical probability. So before finding this theoretical probability, we will study some of the terminology like elementary events. Elementary events. What are elementary events? Elementary events. So elementary event or events, what it is? An event containing only one outcome. An event containing or an event having only one outcome. Having only one outcome are known as, or one outcome is known as it is elementary outcome. Elementary event. So now when we toss a coin, what are the possible outcomes when we toss a coin? When a coin is tossed, the possible outcomes are, what were the possible outcomes? We get either head or a tail. Head or a tail we get. Now what is the probability of getting a head? Probability of getting a head. So let P of H stands for it is head. Probability of getting head is equals to number of favorable outcomes of getting head, that is 1, divided by total number of favorable outcomes, it is 2, that is 1 by 2. Similarly, what is the probability of getting a tail? That is P of T. T stands for a tail. So number of favorable outcomes of getting a tail is equals to, it is 1, divided by total number of favorable outcomes, it is 2, 1 by 2. By adding, this is P of H is plus P of T is equals to, what we get is 1 by 2 plus 1 by 2, that is 2 by 2 will get 1. So what are this, as I said, it is getting a head and getting a tail. It is, those events are known as elementary events. From this what we can say that therefore the sum of all probabilities of elementary events is 1. The sum of all elementary events, the sum of the probabilities of all elementary events is of 1. Now if I see here, how many outcomes we got? Only 2 outcomes we got, that is head or tail. So this is the probability of getting a head, and this is outcome to getting a head, and this is outcome to get a tail. So what we can see, this other words, it is this one, it is probability, an outcome getting not a head. Here it is probability of getting a head is equals to 1 by 2, and this is probability of getting a tail is 1 by 2. So probability of getting a tail also we can consider as probability of getting not a head. So P of T, that is P of T, also we will consider as also known as, what we can call it as probability of getting not a head. So this can be represented as P of T, also can be represented as P of E bar. That bar represents what it is, not E. P of not E. So we can write in words as P of not E. So these elements are known as, what they are known as, it is P of not E. These elements are known as complementary elements. P of not E. This kind of elements are known as complementary. That is here it is P of H plus P P of not H, that is this one, is equals to 1. So P of E means it is event. Here what is the event? It is head. So replace this as what? With the H, and here also it is H. So now from this P of H is equals to what it is? Probability of H is equals to, when we transpose to the other side, we get 1 minus P of not H. P of not H, or P of not H, that is equals to what it is? 1 minus this is, when we transpose this, we will get it is 1 minus probability of getting what it is, a head. This is probability of getting not a head, means it is a tail. So these kind of elements are known as what? This element is known as what it is? Complementary element. Complementary element. So elementary events, I said it is the sum of all probabilities of elementary events is 1. If we know the sum of all the elementary probabilities of elementary events is 1. If we know any one event from that elementary events out of 2, we can find the other event probability by subtracting the known probability from 1. So is it clear? It is, children? Now we will discuss about impossible event. The word impossible says it is not possible. So in our topic of probability, impossible event means the events which cannot happen. The events which cannot happen, or the event which cannot happen, are known as impossible event. Which cannot happen are known as impossible events, or the event which cannot happen is known as impossible event. So then what is the probability of an impossible event? When we toss a coin, if the coin is a fair coin and the base is unbiased base, means there is no obstacle. When we toss a coin, is it possible to get a head and tail together? So it is not possible. We call such a type of events are known as impossible event. Similarly, when we roll a die, is it possible to get a number 7 on any face? No. So such events are known as impossible events. So how is there any favorable outcome for impossible event? There is no favorable outcome for impossible event. Therefore, the probability of impossible event it is 0. Probability of impossible event it is 0. So the probability of probability of an impossible event is impossible event is 0. It is 0. So the probability of an impossible event it is 0. Let if P of E, that is E is an impossible event. E is an impossible event, then its probability is 0. That is where E is impossible event. So now we will discuss one more. It is certain or sure event. See here, when we toss a coin, getting either head or a tail, or when we roll a die, getting a number equal to 6 and less than 6. Equal to 6 means it is 1, 2, 3, 4. Sorry, equal to 6 means it is 6, and less than 6 means it is 1, 2, 3, 4, 5. So all favorable outcomes are equal to the number of possible outcomes. Here, for a certain event, a sure event means what is, first of all, what is a certain or sure event? The events which must occur. The event which must occur. Is known as a sure event. So now how to find its probability? So as I said, it is when we roll a die. So what are the possible outcomes we get? It is either 1, 2, 3, 4, 5, 6. 6 possible outcomes are there. Now the event is getting a number less than or equal to 6. less than or equal to 6 means what are the favorable outcomes? It is 1 comma 2 comma 3 comma 4 comma 5 comma 6. Possible outcomes are also same 1 comma 2 comma 3 comma 4 comma 5 comma 6. Therefore, the probability of a certain event is equals to number of favorable outcomes and number of possible outcomes are same, all are equal. Therefore, the probability is 1. Therefore, the probability of a certain event or a sure event is 1. A certain event or a sure event is 1. So the probability of a certain event or sure event it is 1. The probability of an impossible event is 0. And we have discussed when we toss a coin, getting a head is the probability of getting a head is 1 by 2. So from these three, what we can conclude, probability of an event may be 0, probability of an event may be equal to 1, or probability of any event may be in between 0 and 1. 0 and 1. So from here what I can conclude, therefore probability of an event, that is P of E, is greater than or equal to 0. It may be equal to 0 or it may be more than 0, and it is less than or equal to 1. So probability of any event will lies in between 0 and 1 and including 0 and 1. So it will not be more than 1 or it may not be less than 0. Less than 0 means it is negative values. Probability of any event will not have any negative values, and the probability of any event will not be more than 1. So here, is it possible to have a probability of an event is 1.2? No. Why? Because 1.2 is more than 1. 1.2 is more than 1, but the highest maximum probability is 1. Is it is possible to have probability of an event minus 2? It is possible? Again it is no. Is it is possible to have any event 70%? Yes, it is 70%. 70% means it is 70 by 100, that is 7 by 10, which is equals to 0.7, which is less than, again it is 1. Which is less than, again it is 1. So always the probability of any event will be either 0 or 1 or in between 0 and 1. Is it clear, children? How probability of an impossible event, probability of a certain event or a sure event. Now we will discuss when we toss one coin is tossed, what are the possible outcomes? It is a head or tail. When two coins are tossed at a time, that is simultaneously, what are the possible outcomes? First coin is head, second coin is also head. First coin is head, second coin is tail. First coin is tail, second coin is head. Second coin is head, first coin is also head. That is H, T, T and T. So similarly, when three coins are tossed simultaneously, what are the possible outcomes? Not favorable outcomes. It is a head, then head, tail. Then head, tail, head. It is head, tail is one possible outcome. Then tail, head. Then tail, head, tail, head. The last one, it is a tail. So how many possible outcomes we get when three coins are tossed simultaneously? It is we get 8 possible outcomes. When two coins are tossed, how many possible outcomes we will get? It is 4 possible outcomes we will get. And when one coin is tossed, how many possible outcomes we will get? Only 2 possible outcomes we will get, that is head and tail. So similarly, when one die is rolled once, then what are the possible outcomes we will get? Here it is 1, 2, 3, 4, 5 and 6. So 6 possible outcomes we get when we roll one die at a time. So if we roll 2 dice, then what we get? 2 dice. If you roll, what we get possible outcomes? We'll see here. The first die is 1, second die is also 1. First die is 1, second die is 2. That is 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5 and 1 comma 6. Similarly with the 2, 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4 and then 2 comma 5, 2 comma 6. Then 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6. Then with 4, if the first die it is 4, 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 4 and then 4 comma 5, 4 comma 6. Then with 5, 5 comma 1, 5 comma 2, 5 comma 3 and then 5 comma 4, 5 comma 4, 5 comma 5, 5 comma 6, 5 comma 6. Then 6 comma 1, 6 comma 2, 6 comma 3 and then 6 comma 4, 6 comma 5, 6 comma 6. So total we'll get 36 possible outcomes we get when two dice are rolled simultaneously. How many it is? 36 possible outcomes we'll get. Here it is 6 possible outcomes and here in this case it is 8 possible outcomes we'll get. Is it clear, children? How many possible outcomes we get when one coin, two coins, three coins and one die, two dice are thrown simultaneously. Here simultaneously means what? Together at a time, the same time two dice are rolled or two coins are thrown or three coins are thrown. Is it clear, children? Yes? Now on this topic n number of questions can be asked here. Find the probability of an event having same number like this is 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6. Or find the probability that the second number is a factor of the first number. Second number is factor of the first number, or the second number is multiple of the first number. Like this n number of questions can be asked on this concept. Now we will discuss about the cards, playing cards. Playing cards, what are the favorable outcomes or possible outcomes is possible for playing cards, we will discuss. So a deck of cards contains 52 cards will be there. 52 cards, total cards are how many? 52 cards. In this we have two colored cards are there. First color it is what? A red color is one. The other one it is black color is one. Black color cards and red color cards, equal number of cards are there. So red color cards are how many it is? 26. And black color cards how many are there? It is again 26. So these red color cards are classified. We have two types are there, and black color cards also we have two types are there. Two types are there. So what are the two types in red color? It is a diamond is one. Diamonds. We call it as diamond colored cards. It is one. And then it is hearts also is there one. Hearts. Diamonds and hearts. Diamonds and hearts. Here it is clubs and spades. Clubs and spades. Spade or spades are there. So four types of cards are there. Two are red color and two are black color. Red color cards are diamond cards and hearts. Clubs and spades are black in color. So each again is diamond color cards we have 13 are there. Hearts we have 13 are there. Clubs 13 are there, and spades it is also 13 are there. So now each set of diamond or hearts or clubs or spades we have an ace is there. Ace, then king is there, king, jock, and then what it is, queen is there, queen, and the numbers are 10, 9, 8, 7, 6, 5, 4, 3, 2. So these 13 cards will be there for all the four types of cards, that is diamond cards, hearts, clubs and spades. So in diamonds we have one ace card, one king, one jock and one queen. Similarly hearts also we have ace, king, jock and queen are there. So 10, 9, 8, 7, 6, 5, 4, 3, 2. These cards are known as number cards. Number cards. Now if you see here, if you observe these playing cards on king, jock and queen, these king, jack and queen, we have faces are there, and these cards are known as face cards. Face cards. So how many face cards are there in diamonds? It is 3 face cards, 3 face cards in hearts, 3 face cards in clubs, 3 face cards in spades. Total how many face cards are there? 12 face cards are there. How many face cards are there? 12 face cards are there. Ace is not a face card. Ace is not a face card. So this is about the number of playing cards. About this, how many cards are there? Red color. How many cards are there? Black color. How many diamonds? How many red color kings are there? 2 red color kings are there. That is 1 diamond and 1 heart. One again from black also. 2 kings are there, 1 club and 1 spade, that is in black color. So how many hearts, how many jocks are there, how many queens are there? It is based on the color, it is differentiated as 2 types of cards, that is red and black. Based on their shape, it is a diamond, heart, club and spades. 4 types of cards were classified, and each type we have 13 cards are there, and those 13 cards are ace, king, jack, queen, 10, 9, 8, 7, 6, 5, 4, 3, 2, and these are known as number cards, that is 10 to 2, they are known as number cards. King, jack and queen are known as face cards. Ace, it is not a face card, it is not a face card. Ace is not a face card. So that you should be able to identify the different classification of playing cards. Here also n number of questions can be asked based on their color and based on the, that is the numbers, or that is the face cards, whatever it is there. Now with this concept we will solve some of the problems related to this concept from the exercise. Is it clear, children? The different possible outcomes of playing cards and 2 dice when we roll, or 1 die when we roll, or when we throw 1 coin, 2 coins, 3 coins. Is it clear, children? Now we will discuss exercise sums. Now exercise number 15.1, fifth bit. If P of E is equals to 0.05, what is the probability of not E? Probability of not E. So we know that what it is, P of E plus P of not E is equals to what it is, 1. P of E is equals to 0.05 plus P of not E is equals to, it is P of not E is equals to 1. Now P of not E is equals to, P of not E is equals to 1 minus 0.05. How much will get when we subtract 0.05 from 1? We get 0.95. That is 1 means it is 1.00, 0.05. So while we are subtracting, go for borrowing. Then will be 10. 10 minus 5, it is 5. Here it will be 9. 9 minus 0, it is 9. And here it is 0. 0 minus 0, it is 0. So 0.95. Therefore, P of not E is equals to, P of not E is equals to 0.95. Like this, we will find the probability of P of not E. Sixth question. A bag contains lemon flavored candies only. What kind of flavored candies are there? Only lemon flavored. So Molly takes out 1 candy without looking into the bag. She did not look into the bag and she took 1 candy. What is the probability that she takes out an orange flavored candy? Do you find any orange flavored candies in the bag? No. Why it is? It contains only lemon flavored candies only. Lemon flavored candies only. It contains only lemon flavored candies. Therefore, the probability of what it is, an orange flavored candy, it is what? It is an impossible event. Why? It is not possible. Why? Because the bag itself contains only lemon flavored candies. Therefore, the probability of an orange flavored candy, it is 0. It is 0. Now, a lemon flavored candy, what is the probability that she takes out a lemon flavored candy? All our lemon flavored candies are there. Therefore, it is a sure event, that is a certain event. Hence, the probability of a lemon flavored candy is 1. It is 1, as it is a sure event or it is a certain event. I think, is it clear to you, children? Yes? Box contains 5 red marbles, 8 white marbles and 4 green marbles. 4 green marbles. 1 marble is taken out of the box at random. What is the probability that the marble taken out will be a red marble, a white marble, not green? Not green in the sense the remaining all other colored marbles. So how many colored marbles are there here? 3 colored marbles are there. What are the 3 colored marbles? Red, white and green. Red, white and green. Total how many marbles are there? 5 plus 8 plus 4. It is 17 marbles are there. 17 marbles. Out of 17 marbles, 1 marble is taken out at random. If it is red marble, what is the probability? If it is white marble, what is the probability? If it is not green means other than green, that is red and white marbles. So find the probabilities of these 3 cases. So now we will write the given data. So here, so I am taking R for red, number of R for red marbles, W for white marbles and G for green marbles. So N of R means number of red marbles. N of R means is number of red marbles is equals to 5. Similarly, N of white, that is W is equals to 8, and N of green, N of G is equals to, that is number of green marbles is equals to, it is 4. So total number of marbles, that is N of S. S stands for sample space. N of S. S stands for sample space. Sample space, what is sample space? That is the list of all possible outcomes. The list of all possible outcomes of an experiment is known as sample space. So N of S is equals to 5 plus 8 plus 4, that is 17. That is 17. Now we are going to find the probabilities of first case. So here P of R, probability of red. So P of R is equals to, that is the probability of the marble taken out is a red marble, is equals to number of favorable outcomes of a red ball divided by total number of possible outcomes. So here R stands for red marble, sorry I said it is ball, marble. So number of red marbles, this is total number of marbles, all marbles. So N of R is equals to, how much it is? 5, and N of S is equals to 17. Therefore it is 5 by 17. Next, second case, it is probability of a white ball. So that W I have taken. So N of W divided by N of S, that is equals to, N of W is equals to 8. 8 by 17. 8 by 17. Next, the third one is not green. Here it is not green. So probability of not green means it is P of, what it is, not green means G naught. G naught, probability of not green. So G stands for green marbles. G naught means it is other than green. So other than green, what we have, it is red marbles is there and 8 marbles, what is white marbles are there. So probability of red marbles is 5 by 17. Probability of white marbles is 8 by 17. We know both. By adding these two, we can get the result R. Find the probability of green marbles, then that you subtract from what? The probability, it is 1. We know all these are what? Elementary events. As we have studied, sum of all the probabilities of elementary events is always 1. So like that you can do R. The other way is what? Find number of marbles which are not green. Which are not green means red marbles and white marbles. How many are there favorable outcomes to this event? Here the event is not green. 5 plus 8, it is 13. So 13 by 17 we get R. By adding these two, what we get? 5 by 17 plus 8 by 17 is also equals to 5 plus 8, it is 13. 13 by 17. Like that also you can do. That is, it is 5 by 17 plus 8 by 17, which is equals to 13 by 17. Or as I told here, count the green marbles. It is 4 green marbles are there. Other than green, this is not green means other colored marbles. How many other colored marbles are there? 5 plus 8, that is equals to here n of g naught by n of s. N of g naught is equals to 13 by 17. So you can also do in this way also this sum. Is it clear, children? Right. Next, the third question is related to a die. A die is known once. Find the probability of getting a prime number, a number lying between 2 and 6, an odd number. So as I told, n number of questions can be asked: prime number or composite number, or what it is, odd number, even number, less than or equal to 6, greater than 6, greater than 1, and less than 6. Like this, n number of questions can be asked here. So how to solve this? So when a die is thrown once, what is the sample space? Sample space means it is total or possible outcomes. Possible outcomes. So here S stands for sample space. So S is equals to 1, 2, 3, 4, 5, 6. So like this, 6 possible outcomes we get when we die, when a die is thrown once. Now n of s is equals to, what is n of s? Number of all possible outcomes. How many are there? 1, 2, 3, 4, 5, 6. So n of s is equals to 6. Now what it is? Prime number. Let prime number it is, you take it as p. P stands for prime number. So how many prime numbers are there here? From 1 to 6, 2, 3, 5. Right? 2, 3 and 5. So now, so what it is? N of p is equals to number of prime numbers is equals to 3. Number of prime numbers is equals to 3. So we can find the first one. What is first one? It is a prime number. So that is p of p, probability of a prime number. Probability of a number which is a prime number is equals to n of p divided by n of s. That is equals to 3 by 6, which is equals to 3 ones are 3 twos are 1 by 2 will get. Now similarly the second one, what it is? A number lying between 2 and 6. So what are the numbers which are lying between 2 and 6? Let that event is E. Let that event is E. So E stands for what? Numbers lying between 2 and 6. Between 2 and 6 means 2 and 6 both are excluded. So now what are the numbers which we have here? It is so between 2 and 6 is 3, 4 and 5. So n of E is equals to what it is? Number of possible favorable outcomes of event E is 3. Therefore P of E is equals to n of E by n of E divided by n of S. N of S means total number of possible outcomes, it is 6. That is equals to again 3 by 6. 3 ones are 3, 3 twos are 6. We get 1 by 2. 1 by 2. This is the second one. Next it is third case. It is the numbers are odd numbers. Odd numbers. So let I am taking O as the event. So O stands for what? Odd numbers. So how many odd numbers are there? 1, 3, 5. 1 comma 3 comma 5. That is n of O stands for odd numbers. 3 are there. Therefore probability of an odd number is equals to n of O divided by n of S. That is equals to 3 by 6. 3 ones are 3 twos are. Again we get 1 by 2. What we got here is 1 by 2. If you observe the three cases, we got the same probability, that is 1 by 2, 1 by 2, 1 by 2. That's why we call these three events what is equally likely events or equally likely outcomes. These outcomes are known as equally likely outcomes. So like this we find. Similarly we discuss when two dice are thrown once simultaneously, what were the questions will be framed and how to solve those we'll discuss. Is it clear, children? Now we will discuss 14th problem from exercise number 15.1. One card is drawn from a well shuffled deck of 52 cards. As I explained, that well shuffled deck of deck means it is 52 cards are there. From that 52 cards, one card is drawn. That is, one card is removed or taken out. Find the probability of getting. We need to find the probability of getting. The card is a king of red color. A king of red color. a face card, a red face card, the Jack of hearts, a spade, the Queen of diamonds, the Queen of diamonds. So here, as I told in the previous class, the deck of 52 cards. So 52 cards we have. From that 52 cards we have 26 and 26 are what? These are black and these are red. Black and red. Again from here, from red color we have 13 cards are there, and here we have 13 cards are there. 13 cards and 13 cards. Here 13 cards and here it is 13 cards. So red color cards are what? Diamonds, and here it is hearts. Diamonds and hearts. Here spades and clubs. Spades and clubs. So from each 13 cards, what are the cards which we have? It is the number card 2, 3, 4, 5, 6, 7, 8, 9, 10 and Jack, Queen, King and Ace. Like this we have. So 13 cards are there. 6, 8, 10, 13 cards are there. From each group. So 13 diamonds, 13 hearts, 13 spades and 13 clubs are there. Now based on this the questions are given. The first question. A king of red color. So here red color cards, how many are there? 26 cards are red color. From that how many kings are there? One from diamond and one from hearts. So total how many red color kings are there? 2 kings divided by total number of possible outcome, that is the total number of cards are, it is 52. So simplify, 2 ones are, 2 twos are, 2 six are. So it is 1 by 26. 1 by 26. Now B beat. A face card. I told Jack, Queen and King. These 3 cards are known as face cards. And 3 cards are there from diamonds, hearts, spades and clubs. Total 3 plus 3 plus 3. It is total how much it is? 14. Sorry, 12 cards are there. 12 divided by 52. 52. So 4 threes are 12. 4 threes are 12. Then 4 ones are 4. 4 threes are 12. That is 3 by 13 we got. 3 by 13 face cards. That is a face card if it is a red colored face card. How many red colored? These red colored cards here, 3 face cards are there, and here 3 face cards are there. Total 6 face cards are there. 6 by 52. That is 2 threes are, 2 twos are, 2 six are. It is 3 by 26. 3 by 26 we got. Next, D beat. The Jack of hearts. Hearts. How many jocks are there? Only 1 jock. Therefore, it is 1 divided by 52. 52 are total cards. Next, a spade. So, how many spades are there? 13 spades are there. Therefore, it is 13 by 52. 13 by 52. 13 ones are, 13 fours are, which is equals to 1 by 4. Then F. It is the Queen of diamonds. Queen of diamonds. So diamonds are there. How many queens are there in the diamonds? Only 1 queen. Therefore it is 1 by 52. So be thorough with this. Cards, their color and their names. Face cards which are not face cards. Is it clear, children? Right? Now the 16th question. Here it is. So there are 12 defective pens are accidentally mixed with 132 good ones. So 12 defective pens means damaged pens are there. Those are accidentally mixed with the good ones. Good ones how many are there? 132 good pens are there and 12 defective pens are there. It is not possible to look at a pen and tell whether or not it is a defective. It is not possible to say that by looking into the pens whether it is good pen or whether it is a defective pen or good pen. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So, if that pen is a good one, means here the event is getting a good pen. How many favorable outcomes are there for good pen? That is 132. Total number of possible outcomes means total number of pens, that is good pens plus defective pens. Together it is. So we need to find the probability that the pen is a good one. The pen is a good one. So we will take good one is G. The letter G we take. G stands for number of good pens. Right here. Number of good pens. So number of good pens is equals to how much it is? 132. Then that is n of G. Here G stands for good pens 132. So n of D. D stands for defective pens. How many pens are there? 12 defective pens. N of S, that is total sample space, all possible outcomes. That is 132 plus 12. That is equals to 144. 144 pens are there in that. Few are defective and the remaining are good pens. Now what we need to find? Find the probability of the pen is a good one. So that is P of G. P of G means probability of a good pen. Probability of getting a good pen is equals to favorable outcomes of getting a good pen, that is n of G. N of G divided by total of all possible outcomes. Total all possible outcomes, that is n of S. That is equals to n of G is 132 by 144. 132 by 144. So 12 ones are 12 twos are. This is 12 ones are 12 ones are. So how much it is? 11 by 12. 11 by 12. Like this. Then what is the probability that the pen is a defective pen if it is asked? So defective pens are 12 divided by total possible outcomes, it is 144. 12 ones are 12 ones are 144. We get 1 by 12, or subtract this good pens from 1, we get 1 minus 11 by 12 is also equals to 1 by 12. That question is not asked in the question. If it is asked like that, we need to do it. Is that clear, children? Yes? Now we'll discuss the 17th question from exercise number 15.1. 2 bits are there. A lot of 20 bulbs contain 4 defective ones. So there are 20 bulbs are there. From that 20 bulbs, 4 defective ones means damaged bulbs are there. One bulb is drawn at random from the lot. What is the probability that the bulb is defective? So how many defective bulbs are there? Here it is. Defective bulbs it is 4. You can take it as n of D. N of D means is number of defective bulbs 4, and n of S means total number of bulbs. Total number of bulbs, how many are there? 20 bulbs are there. In that 4 bulbs are damaged one, that is defective ones. Now what is the probability that this bulb is defective? That is P of D is equals to probability of a defective bulb is equals to n of D divided by n of S. That is equals to 4 by 20. 4 ones are 4 5s are 20. It is 1 by 5. 1 by 5. Now second bit. Suppose the bulb drawn in question 1 is not defective. So one bulb is drawn in this bit. If that bulb is not a defective bulb, means what? It is a good bulb and is not replaced. Then it is again not added to that group of bulbs. So when it is not added to the group of bulbs, then how many bulbs will be there? Here it is. One bulb is removed and it is not replaced. Therefore, the number of bulbs left over, that is n of S is equals to 19. 19. Why it is 19? Because one bulb is removed and it is kept aside. Now, one bulb is drawn at random from the rest. The rest of the bulbs, how many are rest of the bulbs means remaining bulbs? How many are there? It is 19. What is the probability that this bulb is not defective? It's not defective means it is a good bulb. So what is the probability of that bulb which is good? It is acting n of G. G stands for good bulb or not defective. So how many good bulbs are there? Say here one bulb is taken out from the lot, and if suppose it is not defective one means it will be a good bulb. So total good bulbs are how many are there here? This is total number of bulbs, and you take n of G, that is the total number of good bulbs is equals to 16 will be there. How many will be there? 16. So out of 20, 16 are good. and 4 are damaged. So one bulb is taken out. If that bulb is not defective, means it is a good bulb. Therefore, number of good bulbs are how many? It is 15. Or the number of bulbs which are not defective is 15. Which are not defective is 15. Therefore, the probability of the bulb which is not defective or the bulb which is a good one is how much? N of G divided by N of S, that is 15 divided by 19. 15 divided by 19. Like this we will find out the probability of the required event. Now a box contains 90 discs which are numbered from 1 to 90. So there a box is there, in that box some discs are there and numbers are written on those discs from 1 to 90. If one disc is drawn at random from the box, so find the probability that it bears a 2-digit number. So how many discs are there with 2-digit number we need to find, then we can find its probability. Is a perfect square number. How many perfect squares are there from 1 to 90 we need to find, then we can find its probability. On a number divisible by 5, how many numbers are divisible by 5 from 1 to 90, then we can find the probabilities. So here, what is the total possible outcomes is N of S is equals to 90. N of S is equals to 90. Now, first bit. A 2-digit number, I am taking a 2-digit number as it is a D I am taking. So N of D is equals to, N of D means is number of 2-digit numbers. D stands for number of 2-digit numbers. So number of 2-digit numbers, how many are there from 1 to 90? 1 to 90, how many numbers are there? 90 numbers are there, and from 1 to 9 there are 1-digit numbers. So 2-digit number starts from 10. Therefore, 90 minus 9, which is equals to 81. So 81 2-digit numbers are there. 81 2-digit numbers are there. Now, probability of a 2-digit number. Probability of a 2-digit number is equals to N of D divided by N of S. That is equals to what? N of D is equals to 81 by 90. 9 nines are 81, 9 tens are 90. That is 9 by 10. 9 by 10. Now second one it is perfect squares. Perfect squares I am taking S. Sorry, I will take P. So number of perfect squares. So first we find out the perfect P stands for perfect squares. What are the perfect squares which are there from 1 to 90? Is 1 is one number. 4, 9, 16, 25. After that it is 36, 49, 64 and 81. So N of P, that is number of perfect squares are, how many are there? We have 9 perfect squares are there, that is equals to 9. Now probability of the number which is a perfect square is equals to N of P by N of S. So N of P is equals to 9 and N of S is equals to, that is 90. 9 ones are 9 tens are, that is 1 by 10. Now third one, that it is a number is divisible by 5. So 1 to 90, how many multiple divisible by 5 means those numbers are nothing but multiples of 5, like 5, 10, 15, 20, 25, 30, 35, 40, 45 and so on till 90. How many we get? 18 5s are 90. Therefore, there we have 18 multiples are there. 18 numbers are there which are divisible by 5. So I am taking number divisible by 5. So let's third one I am taking. So numbers divisible by 5. So I am taking that is what it is, probability of a number divisible by 5 is equals to, how many are there? 18 by 90. 18 ones are 18 5s are, that is equals to 1 by 5 is the probability of that number which is divisible by 5. Like this we will find the probabilities of the events which are given in the questions. Is it clear, children? Right? Now we will discuss 24th question from this exercise number 15.1. A die is thrown twice. 2 times is nothing but throwing 2 dice simultaneously. We will read here for this problem. It is given hint. What is the probability that 5 will not come up either time? 5 will come up at least once. At least once. You see here. Will not come up either time means 5 should not be there. 5 should not be there. 5 will come up at least once means at least for one time the number 5 should be there. By adding these two, what we get, the total possible outcomes only we will get it. Now we will write what are the total possible outcomes when 2 dice were thrown. When 2 dice were thrown, what are the possible outcomes? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 6, then 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, 6 with 4 means, what does it mean? 1, 1 means first die is 1, second die is also 1. First die is 1, second die is 2. First die is 1, second die is 3. First die is 1, second die is 4. Like this. Again here, first die is 2, second die is 1. These two are different. This is first die is 1, second die is 2. Here first die is 2, second die is 1. Like we will have different meanings. With 4, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6. Similarly, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Then 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So total, now what is the total number of outcomes we got? It is n of s is equals to, we have 36 are there. So now the first bit, what is the first bit here? It is find the probability that 5 will not come up either time. We identify for which outcomes 5 is not there. You see here, first you locate there, which is having 5 located. So this is there here, it is having 5, 1, 5, 5 is there, 2, 5, we have 1 is there, 3, 5 is there, 3 are there, then 4, 5, we have 1 outcome is there, 5, 1, 5, 2, 5, 3, 5, 4, 5, 6, 5, and 5, 6, 6, 5. So these observations or these outcomes, they have 5 is there either at least once or 2 numbers also 5 is there here. So how many are there? How many outcomes are containing 5 is one number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 outcomes are there for which at least 5 is there. At least 5 will be there once. Our question first will, 5 will not come up either time. 5 will not come up either time means there is no 5 either in the first die or in the second die. So the remaining leftover outcomes will support the first bit, that is 5 will not come up either time. How many are there? Total 36 are there. Out of 36, 11 outcomes are having 5 either time. 5, at least once we have 5 is there in the 11 outcomes. The remaining outcomes, how many are there? 25 outcomes are there, that is 36 minus 11 is equals to 25. 25 outcomes is not having 5 at that time. Therefore, the probability of the first bit one, it is P of E is equals to n of n of E divided by n of S, that is equals to 25 by 36. 25 by 36. Now second weight it is already we got the answer. So 5 will come up at least once. How many we got? 5 will come up at least once. We have 11 are there. Rounded all these I have circled. Those outcomes will represent 5 will come up at least once. Therefore, the probability of F is equals to, F stands for 5 will come up at least once. That is equals to 11 by 36. 11 by 36. Is it clear, children? Yes? So like this we will find when 2 dice are thrown simultaneously or 1 die is thrown twice. Is treated as 2 dice thrown simultaneously. I hope you understand today's concept.